Hello students, welcome to Ahuja classes Smartness in Education. Today we are going to learn about the new concept that is the fluid mechanics, and this is part 1 in which we learn about some basic concepts of fluids. Now the question arises, what is the fluid mechanics? Fluid mechanics is composed of basically two words. The first one is the fluid, which refers to the substances which have property to flow. Substances which have property to flow. And what are these substances? These are basically what? Liquids and gases. Now, and the next word is mechanics, which deals with the study of forces and motions. Study of forces and motions. So, we can define the fluid mechanics as is the branch of science which deals with the behavior of the fluids, that means liquids or gases at rest as well as in motion. Now, the mechanics is divided into two categories. In the similar manner, the fluid mechanics has also been divided into two categories. That is what? Fluid statics, and second one is fluid kinetics. Statics refers to the study of fluids when they are at rest. The study of, in this case, the study of forces is done on the fluids. And the second is the fluid kinetics, in which the study of fluids in motion are studied. When the fluids are in the condition of motion, then the concept of kinetics are applied. And fluid kinetics has also been divided into two categories. First one is fluid kinematics and second one is fluid dynamics. Kinematics basically refers to the study of motion of fluids without considering the forces which are causing the respective motions, whereas in the dynamics we are concerned about the study of motion as well as the forces which are responsible for that particular motion. Let's see, this is a bucket. In this, the water is placed in the rest position, and this is the dam through which the water is flowing, and that is the case of the motion of the fluids. Now, we are going to talk about the basic properties of fluids. The basic properties of fluids are basically, first one is density or mass density, second is weight density or specific weight, next is specific volume, and next one is specific gravity. Let us talk about these properties one by one. Density or mass density. Density or mass density basically refers to the mass of fluid per unit volume of a fluid. The mass contained in a unit volume of a fluid is known as density or mass density. It is represented by the Greek symbol rho. So suppose, for an example, suppose 10 liters of liquid contains 5 kilogram of the liquid. 10 liter is equal to 5 kilogram. So 1 liter will contain how much kilogram? 5 by 10 kilogram. So that means the density is 0.5 kilogram per liter. This is the mass density, which is the mass upon volume. So mass density is denoted by the symbol rho. In SI system, it is measured in kilogram per meter cube. Mathematically, it is represented as the ratio of mass of fluid to the volume of the fluid. The density of water is given as 1 gram per centimeter cube, or if you convert the gram into kilogram and centimeter into meters, then you get 1000 kilogram per meter cube. Now, the specific weight or weight density. This is similar to the mass density, but in this case, the weight is taken in place of mass. So, weight density can be defined as the weight per unit volume of a fluid. So, weight density is represented by a small w and its unit is Newton per meter cube, because weight is a kind of force. So mathematically we can represent weight density as weight of fluid to the volume of fluid. Now weight can be defined as mass into acceleration due to gravity upon volume of the fluid. Now we know that the ratio of mass to the volume of the fluid, mass upon volume is mass density, that means rho, and acceleration due to gravity is g. So we can represent the weight density as W equals to rho g. The value of specific weight or weight density for water is given by 9.81, which is g, and this is rho for water, that means 9810 Newton per meter cube in SI units. The next property is specific volume. Specific volume is basically the inverse of the mass density of the fluid, and it can be also defined as the reciprocal. It is the basically reciprocal of mass density. Reciprocal of mass density, that means rho. Now in words, we can write it as the volume of a fluid occupied by unit mass or volume per unit mass of a fluid. So, suppose in the previous case we have taken the example of 10 liters of fluid, which was containing 5 kilogram of mass. So, if I write 1 kilogram of liquid will be occupied in 10 by 5 liters of volume. So this is the specific volume, 2 liters per kilogram. So we can 1 kilogram contains 2 liters of the fluid. So generally the specific volume is basically applied to the gases. It is volume of a fluid to the mass of the fluid, or we can write it as 1 upon mass of fluid upon volume of fluid. This term refers to the mass density rho. It is expressed in SI system. It is expressed in meter cube per kilogram. Specific volume is commonly applied to gases. Now, the next property is specific gravity. Specific gravity is basically the ratio of weight density or simple mass density of a fluid to the weight density or mass density of a standard fluid. In case of gases, standard fluid is taken as air, whereas in case of liquids, standard fluid is taken as water. So that specific gravity for liquids is given by weight density or density of liquid to the weight density or density of water, and for gases it is weight density or density of gas to the weight density or density of air. Now specific gravity for water is 1 and specific gravity for mercury is 13.6. Let us discuss about some problems based upon the properties of fluids. The first problem is calculate the specific weight, that means a small w weight density, specific weight density, that means rho, and specific gravity capital S of 1 liter, that means volume of the liquid is given as 1 liter, and 1 liter is 1 upon 10 raised to 1000, 1 upon 1000 meter cube, which weighs 7 Newton. That means weight of the fluid is given as 7 Newton. Now, to calculate specific weight, we know that specific weight is given by weight of liquid to the volume of liquid, capital W upon V. That means 7 upon 1 upon 1000, so we get 7000 Newton per meter cube. And in the second case, we have to evaluate density rho, which is given by mass of liquid to volume of liquid. Now mass will be weight upon gravity to the volume. Weight is 7 upon 9.81 divided by 1 by 1000. So we get 7000 divided by 9.81. That means approximately 700 kilogram per meter cube by taking gravity as 10. And at the last we have to calculate specific gravity, which is given by mass density or weight density of the fluid with respect to the mass density or weight density of the standard fluid. Of here the standard liquid will be water. So we have mass density of liquid as 700 and mass density of water is 1000, so that this will be 0.7, and it is a unitless quantity. Now The next problem is we have to calculate the specific weight, density and weight of 1 liter of petrol. 1 liter of petrol, that means volume is given as 1 liter, that means 1 upon 1000 meter cube, having a specific gravity as 0.7. Specific gravity is given as mass density of liquid. Here the liquid is petrol with respect to the mass density of water. It is 0.7 and we have to calculate the mass density of liquid, that means petrol, and it is 1000. So the mass density of petrol will be 0.7 into 1000, that means 700 kilogram per meter cube. This is our first answer. And we have to calculate a specific weight, that means weight density, which is given by mass density into gravity. This is 700 into 9.81. So we approximately get weight density as 7000 Newton per meter cube, and at the end we have to calculate the weight of 1 liter of petrol. So weight can be measured as a specific weight equals to weight upon volume. That means a specific weight is 7000 and we have to measure the weight, and volume is 1 upon 1000. So weight will be 7000 into 1 upon 1000, that means 7 Newton per meter. That means the weight will be 7 Newton. Thank you. In the next lectures we will discuss about the more concepts of fluid